If you've ever worked on a medium-sized project or larger, you've likely stumbled across a class that looked like, for whatever reason, it was responsible for nearly everything in the application. It had several responsibilities that, even if you tried to justify them with some backbending logic, it had no relation to the class name or any of the other responsibilities of the class. This is often referred to as a God object, an object that knows way too much about the rest of the system. The team at Thoughtbot often claim there are two common God objects in every system: user, and then whatever the other base entity of a system is. So for a project management application, this would likely be the project. The problem with God objects is that because they know everything, they're really hard to work against. There is a lot of code to sift through, and a small change might ripple up and break in obscure locations throughout the code. Sadly, oftentimes in these objects, you'll normally wind up with tons of duplicated code because some developer couldn't be bothered to properly search through it, or the class was too complex for them to see similarities to the code they were trying to implement. These objects are also pretty difficult to test properly because they're hard to isolate or mock out. Finally, they're overwhelming and hard to read. Trudging through 1,000 lines of code sucks, so who wants to do that? Simply put, a God object is the antithesis to the single responsibility principle. The SRP states that a class should only have one reason to change, meaning a class should do one thing or have one responsibility. Now, this isn't saying that your class should only have one method or anything. It's saying all of the behavior should be related and should feel relevant to the responsibility that a class has. We're going to run through an example of how to break down a God object into multiple classes with one responsibility each, and then compose them together. You may notice some similarities to what we did in the episode of composition over inheritance, and hopefully this reinforces the value of composition. Okay, so here is our God object, the user object. It's a beefed up version from our example user class last time. Let's look at what its responsibilities are. So it has the basic CRUD operations from our ORM, it has user registration, email sending, and user authentication. Aside from all these extra things, it has its created this year method, which, believe it or not, is the only thing relevant to itself other than the magic getter and setter at the bottom. User registration involves a user, but it doesn't belong on the user object. Emailing a user a welcome message certainly doesn't belong on a user object. And authenticating a user is a concern for sessions, not users. We're going to break this code into manageable components, but I just want to point out that we aren't going to worry about an example execution file this episode. We're just going to focus on modularizing. So let's start by breaking this out into our user repository we had last time. We're not going to worry about the implementation details, we're just going to make some basic methods here that we can call. We'll define the method find and have it take an ID like before. Then we'll define findAll for finding all the results. And then we're going to add find by username and password. And that'll accept both username and password arguments. And we can assume this is going to handle the password hashing stuff with the password on its own. And then we're going to create save, which will accept the user object to persist to the database layer. So now we can stop extending from the ORM in our class definition, and we now have a user entity free from logic of how to save a user. Okay, so next let's bite off the biggest piece here, user registration. We're going to yank out the register and email registration methods out of the user entirely and open up userregister.php. Now I choose to name my classes as nouns, and this might not be the best name choice, but it does tell us what the class is, the registrar of users. In this empty class, let's dump the clipped code from user, and we'll adjust this in a moment. Let's make a constructor that accepts a user repository and a mailer as arguments, and we'll store them to this repo and this mailer. And then we're going to change references to this to user. Instead of this save, this repo save, and then we're going to pass in user. And then this email user will become this mailer, send welcome email, and we'll pass user into that. Below, let's clip out this email method, and then in the user mailer class below, we'll paste it in. We're going to change the method name to send welcome email, and then tell it to accept the user. Then we'll change this references to user again. And rather than constructing a message and passing it in, we're going to pass in this fetch view welcome. Below, we'll define this public method fetch view. We'll have it accept a single argument of the type of view we want to load, and it'll use some unknown behavior to fetch our mailer template. And that's it for this one. Finally, we'll tackle user authentication. Let's clip out this entire last method from our user object, and then we're going to drop it into the empty user authenticator class. We'll have the constructor accept a repository as an argument, and we'll store that to this repo. Next, we'll change our user fetching implementation to this repo, find by username and password, and we'll pass in username and password. Then we'll change the conditional to only check user. And then we're all done for this class. Now our user entity is super easy to read, and it's extremely simple to use and modify. Also, from this we have multiple components that are easy to share, use, and also understand because they don't do a lot. They all have one responsibility. Our user repository is responsible for the interaction with the persistence layer to fetch and store user objects. User registrar knows how to register a user by storing it to the user repo and then telling the mailer to send out an email. Technically, it does some data validation as well that could be abstracted, but it's relevant enough to what's going on that I don't feel too guilty about it. Our user mailer knows how to send an email of a known email type to a user, and our user authenticator knows how to ask the repo if a user's credentials match, and then how to tell a session to begin for that user. One of the trade-offs of this pattern is that you do have more classes, but I personally find multiple small classes easier to understand than one giant class. The concerns are clearly separated, and the logic reads a bit more like English now. So that's it for this episode. Next time, we're going to look at how we can protect our domain code from getting too intertwined with the framework of choice, focusing on MVC framework specifically.